So on your notes page, which again, make sure that you mark in your green packet. This is, oh, I guess it's not page 92. Did anybody mark it? What is the page number? It's not 90. 18? Okay. That might make sense because we did, I think, page 14 or something last time.
No, it's on 15.
Okay, page 15. Mark that page just saying that you did these problems, but on your supplemental notes. So the first thing that we're going to do is read through the problem. This problem says that a water wheel supplies a mill, and it has a diameter of 40 feet. You start your stopwatch at point P, which is on the circumference of the water wheel. On an axis through the center of the water wheel, it is parallel to the surface of the water. The water wheel turns at a counterclockwise at a constant rate. 2 seconds later, point P on the rim of the wheel is at its greatest height. The center of the water wheel is located 15 feet above the water and 15 feet to the right of the mill, which is our designated frame of reference. You are to model the distance D of point P from the surface of the water in terms of the number of T seconds. Okay, it's a lot, but we're going to break it down. We're going to break down this problem. And has anybody ever seen a water wheel?
In video games.
Oh, in video games. That's interesting. When we were in Tennessee, we saw like a old-fashioned water wheel. And it was attached to this thing that it would like grind grain. That's what it did. But anyways, this is an illustration. This tells you what it looks like in the packet. Ren, does it show you this picture?
No, I didn't.
No, okay. So yeah, I feel like that this is part of the supplemental assignment. And so it's, to me, helpful to see the picture. So we've got this water wheel and it goes around in a circle, just like going around in the unit circle. And around the unit circle, you can unravel it to make either a sine or a cosine wave based on where you start. So when we make our graphs, which we did last time, I don't think the homework made you make graphs, but I know we did it in our notes. So we've got these 3 lines and they kind of correspond with the way that the circle is made. So we're going to have, I'm going to put one line here, one line at the bottom of the circle, and then one line at the top of the circle. So those are representing my 3 horizontal lines. I know that with any sine wave, with any sine or cosine wave, I'm going to have 5 points. So I'm going to start 5 points. 1, 2, 3, 4, 5. I don't know yet which wave that I'm going to use. It will depend on whether I start in the middle. Anything that starts in the middle is going to be a sine wave. Anything that starts at the bottom, top or bottom line, that would be a cosine graph. So now we're going to go through and let's read the problem and extrapolate some information. It says a water wheel has a diameter of 40 feet. Oh, also off to the side, let's jot down A, B, C, D. I need A, B, C, D. To make my equation, I need all these pieces. I also need to know the period and work backwards. So when we have an equation, we have these pieces and we solve for the period to make our graph. When we have a graph, the graph will tell us the period. And so we'll have our period and we work backwards to find the B value for our equation. So if I know the diameter is 40 feet, then I know from the top to the bottom, right? From the top line to the bottom line, isn't that the diameter? Because it goes from here to here, right? Isn't that the diameter from here to here? So if the diameter is 40 feet, then I know that my amplitude goes from the center to the top or the center to the bottom. How could I find my amplitude if I know the diameter? Do what? Yeah, well, what's the radius if I know the diameter? Half. So I know that the diameter is 40 feet. Let's divide that by 2. So I know that the amplitude, which also corresponds with the radius, is going to be 20 feet. It says that I'm starting right here at point P. So you start at point P. So if I start at point P, then right there at point P, is that at the center or the top or the bottom line? So the center line, and it looks like it's heading heading up because it tells me that arrow. So I have an idea of what my graph looks like. I'm going to start at the center and I'm going to head up, right? And so which graph is this? Sine wave. Is it positive or negative? So I've got a positive sine. That's what function I'm using. Okay, I'm going to keep going, reading through my problem. The wheel turns counterclockwise, so that tells me that I go up. It also has the picture where it's pointing up. Okay, I start my stopwatch. So if I start my stopwatch, what's my starting time? 0. And then it says that 2 seconds later, you're at the greatest height. 2 seconds later, you're at the greatest height. So I know that 2 seconds later, I'm at the greatest height. I could continue that on. It looks like that every critical point comes at another 2 seconds. So then we've got 4, 6, and 8. Can you tell me what the period was? 8 seconds. So it takes 8 seconds to make this full rotation. To find B, you work backwards. And so when you want to find the period is 2 pi over B. To find B, it's 2 pi over the period. So it's 2 pi over 8. It's like the same formula, just now it's over the period. I can reduce that. I've got 2 over 8. That reduces to what? Yeah, it'll be pi over 4. C, when did I start? 0. All right, now let's figure out, we know how far up and how far down we go, but we don't know at what height this is. So that's really the last piece of information that I need. It says the center of the water wheel is located 15 feet above the water. So I know that this has to be at 15. What would the top of the water wheel be? Like, how high does it go? 35. And how far down does it go? -5. What does negative represent here? Like, how is it possible that it's negative? Y'all may have said it, but I was also talking. So how is it possible to be negative? Because it's under the water. So here's how you would label the graph. Of course, the top and the bottom line don't tell me anything about the equation except for finding the amplitude. So what is the D value? 15. Once you have all of this information, you're ready to write an equation. I want to continue with reading though, because it says, and 15 feet to the right of the mill. Does that tell me anything about my equation? No, so it's like extra information. Don't be fooled. So now I'm ready to write my equation. I have my equation and it's saying the distance and our units are time. is equal to, I've got a positive cosine, so I've got 20, sorry, positive sine. I don't know why I said cosine. Sine, and then comes b, pi over 4. My variable is t, and I don't have any shift, so it's just t. And then I shifted up 15. So here's my equation. We're going to check our graph, but when we check it, we're going to also plot a few points along with our equation. So I could plot, like I see 1 point right here. So that would be 0, 15. I could also plot one of these points to make sure that I go to the maximum, correct maximum and minimum values. So I've got 235. I can make sure the minimum is good. So I would be at 6, -5, and then making sure that my period is good. So I end at the right value. I don't think you have to do every single point in between. Like if I start here and it ends here, then this point's going to be correct. I do want to check my maximum, minimum, my starting and my ending points. So I end with a point of 8, 15. So I'm going to show you how to check this in Desmos. So we've got our equation. So we're going to write our equation into Desmos. So I'm going to type it in. And when you type it in, you can use y and x. That's fine. Y equals 20 sine. And you can type in the word pi and it changes it to the variable or the image pi. Divided by 4. Oh, I had to put parentheses around this. I remember I had a problem yesterday when I was checking it. Pi over 4 x plus 15. All right, so I've got this graph. And I need to make sure that it is correct. So I've also got my points that I need to check. I'm going to have to zoom out a little bit. So it's easier to plot the points and make sure that you're at these specific values. So I'm going to put my points in here. So I had the point 0, 15. I had the point 235. I had the point 6, -5, and 8, 15. So I need to make sure that those points, yesterday when I was graphing one of these, the second one, I'll explain what I did. My points didn't match my graph. So that means my equation is wrong. Or I guess my picture could be wrong too, but I need to make sure. So it's got that point is on my graph. That point is on my graph. This point is on my graph. This point is on my graph. So how do you think we did? Good. We did good. Our equation, our equation matches the graph that we sketched out. We're going to be doing the last day, the last unit in here is going to be building roller coasters. And it will be the same situation where we've sketched out our curve. It gives you parameters where you have to know how high it goes, how low it goes. And you're going to make a piecewise function because they don't all have the same maximum and minimum. And this is how we're going to check it. We're going to type in the equation. We're going to plot the points that we want to make sure we're hitting to check and make sure that we did it correctly. So let's do the next problem. Any questions on this one? Are we good? Yes, no, maybe so. How are we doing? Okay, so let's do another one. The next question?
What does it mean when it says to, I think, can you go back to this?
Sure. This one?
It says to model the distance from the water. Oh, that is what we did. Okay.
Yep. Sometimes it's a very fanciful way to write something simple. I mean, so the next one, we've got this Ferris wheel. Okay, where do you typically get on in a Ferris wheel? The bottom. The bottom. There is a Ferris wheel, and I feel like you still get on in the bottom. Maybe it's in France or something that's like the biggest Ferris. I feel like it's France. I could be very wrong. That's this huge Ferris wheel, and it actually goes down into the ground. So you like go into a tunnel, I think, to get on, and then it goes up. It's really a huge Ferris wheel. So most of the time, so is this like 100% at ground level?
Yeah.
I mean, it looks like you're probably a few feet up, right? There's probably some kind of like, I don't know. When I've gotten on Ferris wheels before, there's some kind of like a ramp or something that you go on to get up on into your Ferris wheel. Or it could be even on the ground, but it's not going to drag the ground, or it doesn't go around. Like that is not going to work like that. So we have this idea of the Ferris wheel. We know that when we make a sine or a cosine wave, we're going to have these three lines. One's going to be at the bottom, one's going to be in the middle, and one's going to be at the very top. We haven't read anything about the problem, but we've got a good idea that it's probably going to start at the bottom, just knowing like how people typically ride a Ferris wheel. So this says, as you ride a Ferris wheel, moving counterclockwise. So this one, again, you're moving counterclockwise. That's counterclockwise. You're going at a constant rate. Your distance from the ground varies sinusoidally with time. You're the last seat to be filled at the bottom. And then, so at the bottom, we know we're starting at the bottom. So that's important. I can put my 5 points. 1, 2, 3, 4, 5. And I know that I'm starting at the bottom. So that's important. If I'm starting at the bottom, then my graph is going to be like that. What kind of function is that? It's cosine, but it's a frowny face. So it's a negative cosine. I didn't write down A, B, C, and D. I'm going to do that because I need to find all these pieces. A, B, C, D. And I'm also going to find the period from the graph and work backwards again. And I know it's a negative cosine because it's a frowny face. Okay, so we start. Last seat to be filled. You're starting at the bottom. That's important for what type of function. And then it starts. Let your C be point P located on the circumference of the circle. So you're here and you're going to travel around the circle. Let T be the number of seconds you have. So our variable in the equation is going to be T. The time or the units of measure are going to be in seconds. You find that it takes you 15 seconds. So 15 seconds to reach the top. So 15 seconds to reach the top. When you get on the ride, what is the time? 0. And a lot of time with these sinusoidal equations, a lot of times that's when time starts. Like whatever it is that you're doing or measuring is typically time starts at 0. Every once in a while, it'll be like 15 seconds ago, I noticed blah, 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 but you could still make that time 0. So a lot of times it starts with 0 and our units are in seconds. And then it says 15 seconds to reach the top. So here would be 15 seconds. So how long does it take to complete the ride? 30 seconds. So what can we extrapolate from that? What did this just tell us? What do we know now? We know 2 things now, actually. What do we know? We know the period is 30 seconds. What else do we know? We know the in-between points, but what over here do we know? Yes, we can find B. B would be 2 pi in this case over 30. And again, that reduces 2 and 30 reduce. So we know that this is pi over 15 for my period constant, but I know something else that is over here now. What do I know? Do I know my amplitude? I know, why do I know C? What's that represent? The starting point. C is where you start. So what's my starting time? 0. Okay, now we need to know amplitude and we need to know the middle line. So we got to find some information that tells us that. Now I'm almost done reading. So to reach the, I didn't keep going. To reach the top, 23 feet above the ground. So I know that the top is 23 feet. So I can label that. The top is at 23. Okay, what else do I know? The diameter of the wheel is 20 feet. How does that help me? So if the diameter is 20 feet, if that's 23, then what would my bottom line be? What? 3. So what would my middle line be? Lucky 13. So what would A be? What's my amplitude? How do you know that it's 10? Yeah, you can do the diameter, divide it by 2. So we know that the amplitude is 10. Good job. What's our midline? 13. Now I'm ready to make my equation. I know everything. So does it matter that the center of the Ferris wheel is 30 feet to the right of our designated frame of reference? No. Huh? It matters to Clayton. It matters. It matters. It doesn't matter when we're making our equation. It doesn't really matter. So I'm going to write my equation. I have d of t because it's the distance with a unit of time. I have a negative cosine graph, so I need to make sure that it's negative 10 cosine. My period constant is pi over 15. The units are time. I'm not shifting left or right. And then I am shifted up 13. That is my equation. And to check a few points for my equation, I don't have to check them all, but I definitely want to check my first and last point. I can also check to make sure that I have the correct height or maximum value. These are probably going to fall into place if these 3 points are correct, but you could check them all. I don't think you have to. So I've got my first point would be 0, 13. My second point would be 15, 23. And my third point would be 30, 13. So I'm going to type that into Desmos again. You should type it in. Don't just have me do it. Don't forget it is negative. All right, so all my points are all messed up now because I have different points that I'm checking, and I'm only going to check 3 this time. I have points that don't match up. What did I do? I didn't realize that I did this until just now. What did I do wrong? My equation is either wrong or my points are wrong. What? Why are my points wrong, Logan? Yeah. Well, 3 instead of 13. And I did the same thing yesterday. when I was doing this, except for my points were correct, but my equation I had +3 instead of 13. So I'm going to put this back down and double check my points. That's why I messed up. I'm at 0, but I'm down here at 3, not 13. I messed that up. Oops. Let's fix it. And then what about this point? Is this point correct? 15, 23? What should it be? That's good. What about my last point? 30, and then again, it should not be 13. It should be 3. So let's see if that fixes my graph. So this should be a 3. Not that, 3. This should be a that one was good. This one should be 33. Oh, what did I do in my equation? I typed it in wrong. Yeah, this is kind of what I was doing yesterday. I was like, I know that I have it written down correctly. It is not matching. And so here I'm double checking my equation now. I should have -10 cosine pi over 15 x plus I should have 13, not 3. Now, do my points match up? Yes, and yes, and yes. So sometimes you're like, the shape is good, but it's not lining up. And you kind of have to tinker with it. In this case, the equation I wrote down was fine. The equation I typed in was wrong. And the points I wrote down wrong. So of course they're not going to match up. So troubleshoot with it a little bit. Sometimes it's your mistake. In this case, it was my mistake. But you want to make sure that you can end up with a graph with the points of where you think that they should be. Any questions? Okay. So I think we can do some word problems. Next, I'm going to do question 1 and 2 with you on your homework, and you have to do the others. In fact, I'm telling you that I want you to do all the problems on the homework. They're due on the 24th. I know it says something different on the homework page because I forgot to catch it. It says that they're due on the 30th. It's not the 30th. We came back later last year. So what we do here, the answers, it gives you answers for everything. However, you could possibly have different answers, and that's okay. And I'll show you why. So the way that you start, because these give you the waves, you could start wherever you wanted. Like, couldn't I start right here? And this would be a negative cosine graph, right? I could start when it's down, it would be a negative cosine. I could start up here and it'd be a positive cosine. I could start right here and it would be a positive sine wave. You can start wherever you want to. So I'm going to just identify that I've got my top, my middle, and my bottom line. Everybody see that? You have to identify your top, middle, and bottom line to figure things out. I'm going to have to know, to write the equation of anything, I need to know A, B, C, D. The graph will give me the period, and I have to work backwards to find B. I can start wherever I want to. I think I'll do it different than the way that the homework told you. The homework told us graph number 1 is going to be a cosine graph. So just to be different and to show you that it doesn't matter where you start, I'll make it a sine graph. So if I'm going to make it a sine graph, I have a couple different options. I could start here and it would be a positive sine graph. I could start here. It could be a negative sine graph. I could start here. It could be a positive sine graph. I can start wherever I want to, but I'm going to be easy. I'm going to start here And then that would be 1, 2, 3, 4, 5 points. I chose to start it somewhere where there's not a label, but I could figure it out. So if this distance is negative pi, well, what's half of pi? What's half of pi? Pi over 2. It's not meant to be a trick question. I'm choosing to start my graph where there's not a label. And I have to know what that is. It's going to be negative pi over 2. I didn't do myself any favors because it's not going to be as easy this way. I'm ending at in between 5 and 6 pi. So I'm ending at 5. So we would say that this is half of pi. And then we go, hold on. I'll make it easier for y'all. Let's not start it right there. You can. There's nothing wrong with that. I can start it wherever I want to start it. I'm going to start it. It looks like all the pies are, sorry, all the sine graphs start like that. So in this case, it would probably be easier to start at a cosine graph because you're right at something that's labeled. You can start it here. So let me just clarify. You can start it there and have it be a sine graph, but I think it's going to be easier for us if we start it where there's a cosine because those are when it's labeled. So if I start it here at pi and I go all the way to 7 pi, what was my period? So it's easier to figure out your period. Just pick things that are already labeled on the graph. So if you go from pi to 7 pi, what was your period? Let's count. So we're going from pi to 7 pi. One way that you can figure that out is just 7 pi minus pi. That's going to tell you your distance. It's just the length. So what's my period? What's the period? 6 pi. How do I find B?
Two pi over 6 pi.
2 pi over 6 pi. What does that turn into? Well, it looks like the pi's cancel.
Oh.
So it just equals 1/3. Where does my graph start? Where's the starting point? Where am I saying my graph starts? At pi, and it's starting in a positive direction, right? So we have to make sure that if this is starting at positive pi, that when we make it our equation, it has to be negative when we plug it in. Now my amplitude and my middle line. Well, what's the middle line? Where's it at? 0. So my middle line is at 0. And then how far up does it go? To the top line.
Oh, 2.
And then down 2. So it goes up to 2 and down to -2. So what's my amplitude? 2. I have everything I need to make an equation. So I get y is equal to, I made this a positive cosine. I could have made it a sine graph. I could have made it a negative cosine graph. I have options. So I picked a positive cosine because it was easiest. Do what's easy. Positive cosine, so I've got 2 cosine 1/3 x. And so since this is plus pi, when I plug it in, it has to be opposite. So I have to say minus pi. And then it's not shifted up or down, so I don't have to write plus or minus anything. That's my equation. So really quickly, I'm going to do question number 2 because we don't have a whole lot of time. So I need to know A, B, C, D, and I need to know my period. So really quickly, I can identify that my top line is at 4, my middle line is at 2, and my bottom line is at 0. Since I know that my middle line is at 2. That's D. I know that I'm going up from 2 to 4. I'm going up 2, and from 2 to 0, I'm going down 2. So my amplitude is 2. I'm going to go ahead and start it right there at 0 because why not? So I've got 1, 2, 3, 4, 5 points. That's going to create a negative sine graph. So a negative sine graph, I'm going to start at 0. So I just need to figure out my period. I go from 0 to 4. So my period is 4. To figure out my B, I do 2 pi divided by 4, and that reduces. So 2 pi divided by 4, I get that my period constant is pi over 2. So I'm ready to write my equation. And one thing that you'll notice, so in this graph, it's labeled with pi's. And when you have your equation, there's no pi in the period constant. For this one, the X is labeled with just numbers with no pi's, and you have a pi in your period constant. So they kind of cancel each other out, just something to keep in mind. So it's either in the equation or labeled on the graph, the pi is. So I end up with my equation is y equals, this is a negative sine graph, so negative 2 sine, my period constant, pi over 2 x plus 2. The rest of these problems are due on your own. And